Hello everyone, welcome to the channel. I'm teacher Jeremiah and we're going to look at a question in our Mastering S1 Geometry book. This question is on swallowtail model and algebra. Oh, interesting. So, have a look at the question. ABC is a triangle, D is a point on AC such that AD equals to DC, and E is a point such that BE equals to 2EC. F is the intersection of BD and AE, and the triangle is, area of triangle ABC is 100. We have to find the area of triangle ADF. This question, geometry question, don't even draw for us. What a not nice teacher. So first, let's draw it out. We have triangle ABC, and then D is a point, is AD equals to DC, so it's the midpoint, and then BE equals to 2EC, so it's somewhere along the right here. And we have to connect BD and AE, and then we get F. Okay? So first, when we are given the relationship here, BE equals to 2EC and AD equals to DC, we can represent them in another form in terms of a ratio. So, if AD equals to DC, what will the ratio be? Oh, ratio will be 1:1, and then BE equals to 2EC, so ratio will be 2:1. Okay? And now we know this, we are going to go through two ways in terms of solving this question. One in primary Olympiad and two in secondary math. So, before we go into that, first, we're going to cover some things about a triangle and we need to learn some models. So, first, let's go through is we have this triangle ABC. Yes? And, same with the question, if I give you some ratio of the relationships of the lines, then what can we conclude about the area? If I tell you that there's a point D here and BD equals to DC, if BD is twice of DC, then what will the ratio be? The ratio will be 2:1. Okay? So if we have this ratio, can you tell me what will the ratio between the area of triangle ABD and ADC be? If the length ratio is 2:1, the height is the same, then the area ratio, it will also be 2:1. 2:1. We call this the equal height model. Okay? So now we know this, let's go one step deeper, even harder. Same, we have a triangle ABC here, we have the line DC here. We already know, yes, the ratio will be 2:1. Now, let's change it out a bit. If I give you another point on AD, let's call E, right here. Okay, what can I say about the area between AEB and AEC? If we know that same here, BD and DC is 2:1 ratio. So here, if we want to see AEB and AEC, what is their ratio in area? First, let's look at the bottom one, BEC, right? What will the ratio area between BED and EDC be? We realize same as the big triangle. We have the ratio 2:1, the height is the same, so the area ratio will also be 2:1. And if the big triangle is 2:1, the small one BEC at the bottom is 2:1, but we minus them, we can get the ratio of AEB and AEC. It will also be 2:1. We call this, because it looks a little bit like triangle, is like AEC is like a swallowtail. We call this the swallowtail model. Okay. Now that we understand these models, we can go into the question. First, let's see. We have the triangle, of course we have to draw it out, and then we need to represent the ratios, right? 2:1 and 1:1 here. And realize if we want to use this model, a little bit tough, because what we need here is we need the same height, and then we know the ratio of the base. Yes, but we don't have any triangles. We have the same height here, but we don't have any triangles with the same base. So what can we do here? Don't worry, if there is no such triangles, what we can do is we can create such triangles. So let's see. If I have triangle BFE here, I want the ratio, I know 2:1. If I want to use the base EC, then I want the same height. What would the triangle be? I can construct line FC. Okay. And now, we have all the ratios, we can start representing. So let's start. First, let's see here. Okay. If I have BFE and EFC, then I know that the base ratio 2:1, and the area ratio will just be the same. So this will be 1 unit and 2 units. I can represent with ratio. Yes? And I know AFD and FDC. What will the ratio be? The ratio will be 1:1. 1 unit is to 1 unit. But are they represent the same thing? Let's see. Let's continue first. First, if we know that AFD and FDC, the total is 2 units. What is the ratio between AFB and AFC? We have learned the swallowtail method just now. It is also 2 units. Sorry, it's not 2 units, it is 4 units, right? Double of AFB. So 4 units. Any problem here? Oh, hold on a minute. First, I can also see it from another way. Because since I know the relationship between AD and DC, if I in a way turn it around, I can compare the ratio of area of AFB and BFC. What will it be? If the length ratio is 1:1, then shouldn't the area ratio also be 1:1? But we see here 4 units, 3 units, they don't match. Looks like this doesn't work. But don't worry. Here, because we need them to match, right? And we know that, looks like BFC total has to be a multiple of 3, right? So we can split 2:1. So what we can do here is let's scratch everything and we represent everything in terms of 3 units. So we multiply by 3. Okay, multiply by 3. First, AFD, if we use 3 units, then I know that FDC will also be 3 units. Yes. And in that case, then AFB, what will it be? Twice. So it will be 6 here and times 2, we got 12 units. Then BFC here will also be 12 units. In that case, BFE is to FEC. We can show that it is 8 units and 4 units. And voila. Now we have ensured that all of the units here in this triangle are representing the same thing. Then we can solve it. So if you add them all up, you realize 12, 3, 3, 4, 8. Total we have 30 units. We want to find AFD, which is 3 units. So 30 units gives us 100. So how much will it be? 3 units is just 10. Simple as that. Solved. So this is the primary school way, primary Olympiad way of doing this. Let's now learn the secondary way. So for the secondary way, realize that, we have to use some basic representation of the same model. So what we have to do is we also have to see that we have to connect FC. Right? And we, of course, we know the ratio. So we connect FC. And now what we can do instead is use algebra. Right? Because we don't know the areas of the triangles, but we know there are relationships. So we can use algebra to represent. So first, we want to find ADF. So let's set ADF as a letter. Everyone will always choose X. Okay. So let area of triangle ADF be X. So if this is X, then what else do we know? We know FDC. Length ratio 1:1, area ratio X and X. And we know that since we know that AEC, this triangle, since the length ratio is 2:1, if you know the whole area is 100, I can also find the area of AEC. Since we know that this is splitting this triangle into 1 out of 3, so we know that, we just need to represent this. But we also don't know how much is the area. Don't worry, we don't know this, we can always set another variable. So we let area of triangle FEC be Y. Yes, and this is Y. Then what will BFE be? You guys are more familiar now. It will be 2Y. And we realize that, BDC, we can also represent it. So now we can solve the question already. First, we know that triangle AEC, right, which consists of 1Y as well as 2X, how much will it be? It's 1/3 of the whole triangle. So it's 100/3. Yes. And next, we have the triangle BDC. It is 3Y plus X. This time it's half, so it's only 50. Yes. So, some of you might realize now, if you learn simultaneous equations, we can now solve it. Yes. We have 2 variables, 2 equations, we can solve for both. But this question only needs us to find area of ADF, so we actually only need to solve for X. So we want to solve for X, what we can do is we want to get rid of Y. Okay. So if you're not learning simultaneous equations, don't worry. This one is a little bit more basic. We can use the elimination method. How to use it? We notice first equation has Y, second equation has 3Y. We want to get rid of Y totally. So it looks like we need to match with 3Y. So first, equation number 1, we can multiply by 3 to make it the same. So we get 3Y plus 6X. we get rid of the denominator, is just 100. Yes, and now, first equation we have 3y, second equation we have 3y, we can name it equation 3. Right, they both have 3y, we can get rid of each other. If we take equation 3 minus equation 2, what do we get? 3y minus 3y, kosong. Then we have 6x minus 5x, we have 5x. And left with how much? 100 minus 50, 50. In that case, x equals to 50. Oh, x equals to 10. My bad. Ooh. 10. So, equation is formed. We found x and we have solved it. So, we realize, this way doesn't require us to do too much in terms of understanding all the units, making all the same and everything. So, let's have a summary of what we've learned today. Very first thing is that no matter what, when we are given multiplicative relationship, we can represent in terms of ratio. And next, we learn some models. Right. First is the equal height model. With the ratio of the base, the lengths, if they have equal height, the area ratio will also be the same. Right. This area is the same as the ratio of the length. Next, the one step higher, we learn the swallowtail model. If we even cut one more time, then the top parts will also have the same area. Yes, the top parts will also have the same area ratio and length ratio. And based on these two, we learn two ways to solve this question. First and foremost, we learn the primary school way. For the primary school way, realize that we need to be very proficient, right? Because we need to use these models very interchangeably. Use here, use there, use here. And not only that, we need to represent them in the form of using units. And not only that, we cannot make the mistake of representing them differently. We need to represent the whole thing in units. So, a bit tough. So first, represent all of them in units and very proficient with the models. Next, secondary method. This one, a bit simpler. What we do is, all we have to do, we still have some basic representation to represent the areas of the triangles. But instead, we can use algebra to represent it. We use algebra to represent and just solve for the variables. So, let's have a look at another question to see if you've mastered how to solve this question. So, we've come up with a practice question. And if you know how to solve it, try it out. And you can leave your answer in the comment section below. The answer will also be in the comment section. Check if you're correct. Okay? If not, then if you have any questions about this question or even more about the practice, you can always contact us in our WhatsApp group over at this link here, or contact me via my link. Okay? And of course, subscribe to our channel. Not only do we have answers for questions in the book, but even some other questions, right, in terms of algebra, everything, secondary 1 questions, and even more in the future. So do subscribe and check out all our other videos. If not, see you next time. Bye bye.